Hey guys, in today's video we're going to look at a couple of pulley problems, one of them involving a flat plane and the other one involving an inclined plane. But let's begin with the pulley problem on the flat plane. Let's call the block on the table block A, and let's call this block hanging down block B. And let's say A has a mass of 0.5 kilograms, so its weight is 0.5 g. And let's say B has a mass of 0.8 kilograms, and so its mass is 0.8 g. We also have a contact force between block A and the table, and that contact force is called the normal reaction force, and it's perpendicular to the plane. And we'll denote it by the letter R. Perhaps in physics you've seen it denoted by the letter N. Let's say that the slope is rough, and so there is friction between block A and the plane. Okay, so which direction is the friction going in? Well, we know that B is trying to pull the string this way, and so it's pulling A to the right, and so friction therefore opposing the direction of motion must be pointing left. And of course we also have the tension in both ends of the string pointing towards the pulley. So we don't know what the value of friction is just yet. However, we can work out the value of R using Newton's second law. So the sum of the vertical forces acting on A, so R minus 0.5 g, are the vertical forces acting on A, is equal to ma. And since we know that block A is not accelerating into the air and it's not accelerating into the table, we know that its acceleration is 0. And so R minus 0.5 g is 0, and therefore R is equal to the weight of the block, which is 0.5 g. And we're now told that B descends a distance of 0.4 meters in 0.5 seconds. Work out the acceleration of B. So let's use SUVAT to answer this problem. So let's write the acronym across the page here. So taking down to be our positive direction, then the displacement of B is 0.4 meters. And of course the time is 0.5 seconds. And since the system was released from rest, the initial speed of B is 0. So we have 3 pieces of information, and we're trying to work out A, and we're not interested in finding V. And so the SUVAT equation we need is the equation which omits the letter V, and so we need the equation S equals ut plus a half at squared. So plugging in our values gives us 0.4 is equal to 0, because ut is 0 times 0.5, which is 0, plus a half at squared, so a half a t is also a half, so we have a half squared from t squared, and so 0.4 is equal to a half cubed times a, or in other words a is equal to 8 times 0.4, which is equal to 3.2 meters per second squared. Let's label on the acceleration of B 3.2 meters per second squared, and of course the acceleration of B is the acceleration of the whole system, and so A is also accelerating to the right at 3.2 meters per second squared. And let's get rid of this arrow just so there are less arrows on the screen. Let's now work out the tension in the string, and let's use Newton's second law on B to work it out. So Newton's second law going down. So the sum of the forces is 0.8 g. Okay, so taking down to be our positive direction again, minus t going up is equal to ma. So the mass is 0.8 and the acceleration is 3.2. So rearranging this is going to give us t equals 0.8 times 9.8 minus 0.8 times 3.2. And so that gives us a value for t is equal to 5.3 newtons. And the last part of this pulley problem is to work out the value of friction. And again, we're going to use Newton's second law, but this time we're going to use it horizontally on A. So Newton's second law horizontally on A. Okay, so pulling A to the right, we have a force of T, which is 5.3 newtons. And opposing it, we have the force of friction. And that's the sum of the horizontal forces. And that's equal to ma. And so the mass is 0.5 kilograms and the acceleration is 3.2. And so rearranging for friction is going to give us a value of 3.7 newtons. Let's now have a look at the pulley problem on the inclined plane. Let's say that the mass of each block A and B is 2 kilograms, and so the weight of each block is 2g. We have a tension in both ends of the string pointing towards the pulley, and again the tensions are equal. And we also have the normal reaction force acting on A perpendicular to the inclined plane. And in this case, R is not going to equal the weight, but it's going to equal the perpendicular component, or the component of the weight that is perpendicular to the incline. We're also told that the acceleration of the system is g over 4. And so B is accelerating down at a rate of g over 4 meters per second squared, and A is accelerating up the slope at g over 4 as well. And we've been told to find the value of theta. So our first step is going to be to calculate the value of tension. And in order to do that, we're going to need to use Newton's second law. And it's probably easiest to use Newton's second law on B. So let's do it vertically on B. So the vertical forces, or the sum of the vertical forces, is 2g minus t, taking down to be our positive direction. And that's equal to ma. So 2 is the mass, and the acceleration is g over 4. Therefore t is equal to 2g minus 2g over 4, or in other words g over 2. And so tension is equal to 2g minus g over 2, which is 3g over 2. And now we're already halfway done. So now we've got to use Newton's second law on A to work out the value of theta. So Newton's second law going parallel to the slope. So the force going up the slope is T, and we have the component of weight which is parallel to the slope opposing it. So if we draw the right angled triangle, we can see that the component of weight that is opposing tension is equal to 2g sine theta. It's the opposite to the angle theta, where theta is the angle between the line of action of the weight and the perpendicular to the slope. And F equals ma, and so we have our mass is 2 kilograms and our acceleration is g over 4. Our tension we've just worked out to be 3g over 2, so let's substitute that in. We get 3g over 2 minus 2g sine theta is equal to 2g over 4, that's g over 2. And actually we can cancel out a g from every term in this equation. So that's a 1. And so that leaves us with 2 sine theta is equal to 3 over 2 minus a half. So 2 sine theta equals 1. Therefore sine theta equals a half. And you might already know that if sine theta equals a half, then theta equals 30 degrees. Hey guys, thanks for sticking around. If you found the video helpful, then hit that subscribe button and comment down below what video you want me to make next, and I'll see you next time.